In this video, let's discuss about lasso regression. Now, lasso regression is also called L1 regularization. Don't be afraid of the heavy term. It's actually linear regression clubbed with regularization that we already covered in the previous videos. Now let me tell you a small story. My friend actually went in to buy a house. Now one of his doors in the house had a standard height and width as you can see in the picture on the left side. But he actually went to a different shop to purchase a door like that on the right side without caring for whether the door will fit the frame or not, without caring about the dimensions of the door frame. He purchased a wooden door. Now let's see what happens. When he brought the door from the shop and tried to fit it in the space provided the door frame, he found that the door was slightly bigger than the frame that was already given, and it was a misfit. So he had to hire a carpenter, and the carpenter chiseled the door, as you can see in the picture. Chiseled the door so that it can fit in the space given. So that is exactly what regularization does. That is, it chisels off parts so that it can fit perfectly. We have already seen this formula in the linear regression video. Now, I have changed a little bit of it. Now my math score is actually 8 times the score in the math in the chapter and exercise, plus B times the study time, C times the problem I solved, plus D times the lecture I attended, plus some kind of project that was E. Now based on this calculation, I calculate the math score based on this formula, and based on the math score I obtain, I find out some kind of error or loss, that is the mistakes I make in predicting the math score. After after I get the error or loss or cost, I do some kind of gradient descent to minimize the loss. And eventually in the process I find out the perfect value of A, B, C, D and E that will minimize the loss. Now the lasso regression or the regularized math code I eventually find out is actually the math code that I predicted previously minus some factor of absolute value of A, absolute value of B plus absolute value of C. That is the individual importance. I subtract that from the actual math code that I predicted, and this is the whole concept of lasso regression. That is, I subtract the importances I give to the individual score in mathematics chapter and exercise, the importance I give to the study time, the importance I give to the problems I solved. You remember the I chiseled off some part of the door to fit the door in the frame. So here also in lasso regression we actually are chiseling off the actual math code so that the error is minimized. Gradient descent which was fitting hardly, we, the door was bigger than the frame, you saw that. Here also the math code was overdoing, so we are chiseling off some part of it. That's the lasso regression. This is the graphical representation of lasso regression. You can see the green line represents the linear regression, and it's still not 100% fit. So we are chiseling off some parts of it, and we have obtained the yellow line, that is the lasso regression line. And this lasso regression line is a good better fit than the linear regression line. See, it's aligning with the points. The points are more or less on the line, yellow line, and the dots that are scattered here and there, those are called outliers. They are to be ignored. So you can see that the yellow line of the lasso regression is much more fit than the linear regression line that we previously obtained. Thank you. That will be all for this video on lasso regression. Now, as you have noticed, I am taking an out-of-box approach in explaining these concepts without involving any kind of mathematics. So your feedback becomes my inspiration and is very important to me. Next, we will study about L2 regression, L2 regularization, or ridge regression as it's called. Thank you and have a nice day ahead. Thank you.